Hi Foundations of Business Analysis students, and welcome to this Excel tutorial on the Univariate t-test. We use the Univariate t-test if we have a continuous variable and if we want to estimate whether the average of that continuous variable is statistically significantly different from some pre-specified parameter. So to explain it in further detail and demonstrate how to perform this t-test in Excel, let's jump into our spreadsheet. The spreadsheet I've got open here is our real estate case study Excel spreadsheet, and the variable of interest is this sales price variable. The hypothesis I want to test here is that the average sale price is significantly different from $255,000. So the way I can test that hypothesis is as follows. The first step into the process is to create a new variable, and our new variable I'm going to call my null. The null is the parameter that I'm comparing my average to. So recall from before, I'm comparing the average sale price to $255,000. So I have to create this variable where every observation is that $255,000 price. The next step in the process after I've created that null is to go to the data menu and select data analysis, and I want to click on the paired two samples for mean test. What I'm actually going to be doing here is comparing whether or not there is a statistical significant difference between the sales price variable and this new variable I've created called null, the null being the average of $255,000. So let's jump into it. Variable 1, I'm going to highlight the range for the sale price variable, which is cell B2 through to B1201. Variable 2, I'm going to highlight that newly created null range. And my hypothesized mean difference is 0 because I'm hypothesizing, my null hypothesis is that there is no difference between the average sale price and $255,000. If I can reject that null of no difference, I prove the alternative that there is a statistically significant difference. The alpha, the significance level I'm going to use here is 0.05. That corresponds with a 95% confidence level, which is the norm in statistical tests. Now click OK, and we get our output as follows. So what we're interested here is our variable 1, that's our sales price variable. We can see that the mean sale price in our sample was $225,701. So that mean sale price was different from our null hypothesis value of 255,000, but was it statistically significantly different? Well, to answer that question, we come down to the bottom here. In this particular case, we're looking at a two-tailed test. A two-tailed test is where our alternative hypothesis does not state a particular direction. So our alternative hypothesis is just that the sale price does not equal $255,000. We're not hypothesizing that that difference should be in any particular direction, such as greater than or equals to. So looking at my critical p-value here for my two-tailed test, that value, 1.75929 times e to the minus 17, is basically 0. It's effectively 0. It's 0.17 zeros, then 1759, etc. So we've got a p-value of 0. Now when we perform this test, we're comparing that p-value to 0.05. If we have a p-value less than 0.05, it means that there is a less than 5% chance the null hypothesis is true. So this p-value is effectively 0, which means that there is effectively a 0% chance the null hypothesis is true. So we have enough evidence to reject the null hypothesis. We reject that null that the average price is equal to $255,000, and we've shown the alternative hypothesis. So a non-statistical explanation of this result would be that the average sale price in this region differs from $255,000. That average price is $225,701. Thanks for watching this video on the Univariate t-test.